Hello, I saw your question in the email. I see that you worked it out already. So the hard part's done. Let's see, we're in 7.3. That's on T distributions. Let's see, a credit card company claims that the mean credit card debt for an individual is greater than $5,300. And so right there it tells me what kind of hypothesis test it's going to be. It says it's greater than $5,300. And so that means the alternative hypothesis is going to be greater than $5,300. The mean's greater than $5,300. So you see, that's this one's a possibility. This one's not. This one's not. This one's not. This one's not. This one. So it looks like D and F both have the mean greater than 5,300. And that's what this says. Now, the null hypothesis should be, I guess, the complement of the alternative hypothesis. So the complement of greater than is less than or equal to. And so that makes it this one. This one here, it uses equal to. I don't think our textbook doesn't follow that path. So it's always the complement. So it looks like you chose that correctly. Now they say find the critical values and identify the rejection. So the critical value, I guess you can see T here, so you don't use T distribution. You need alpha, to calculate this. It's you need to know it's a right-tailed test, and we need alpha. If we look up here, alpha is 0.05, and so I'm just going to use the T calculator. So I want to find the critical values, which means I'm going to use one of these calculators. I'm going to use it's a T distribution. I'm going to use the T calculator here. So it's a right-tailed test. We can see that from our hypothesis. And alpha is 0.05. So I put in alpha. That'll be the area, corresponding to the area here on the right. And I got to put in the degrees of freedom here. Oops, I skipped that. The sample size is 35. So the degrees of freedom is one less than that. So that'll be 34. So let's try this again. 34 there. What did I just have in there? 0.05. It's a right-tailed test. So right-tailed, this area here is 0.05. Sample size is 35, so that makes that 34. We get 1.69, we round to 1, we get that. So that's the critical value. It's a right-tailed test, so anything to the right of that critical value will be the rejection area. So that that tells us this part. Find the standardized test statistic, T. So you can use the formulas they give you. I'm just going to use the calculator here, or the StatCrunch, excuse me. I'm just going to use StatCrunch for that. So we go stats, and we know we're talking about, instead of a Z-stat from the previous section, we know we're talking about a Z-stat, one sample. And if you read the problem, they give you a summary up here. So we already said the sample size is 35, and then let's see, the mean of the sample is 5,416. 5,416, and the standard deviation 600. So that's all given to you there. We're doing, we've already done the hypothesis part. We set it up. It's 5,300. That's the population mean, and it's a right-tailed test. So we need to set that part up from here. And we got that information given to us right here. We click compute, and I guess it'll give us the test statistic, which is 1.43, and the p-value if we needed that, but we 1.14. So we put in there. So we can see the test statistic. Our critical value is, our test statistic is not to the right of the critical value. So we're not going to reject it. We're not in the rejection region. Test statistics is not in the rejection region. The rejection region is anything beyond that. So this value is smaller than that. And so that would be the correct choice. Hope this helps.